So we know that a quadratic equation basically has graphs that can either look like a smiley face or that can look like a sad face. Now, in this video, I want to talk about some special characteristics of these smiley faces or these sad faces. So if I draw my axes over here, given this is my x-axis, that is my y-axis, let's say I have a quadratic equation, and I draw that equation out. So that equation, let's say it has a graph or a smiley face that looks something like this. Now, the important points of this graph or this smiley face are basically this point right over here, this end point, this almost like this bottom point, right? This bottom point right over here, right? These 2 points right over here. Oops, I wasn't supposed to do that. Let me get that back. Hold on. This point right over here, this point right over here, that point right over there. Now, from the previous video, you probably know that this point and this point, these are basically the roots of the smiley face. It's where the smiley face touches the x-axis. And in other words, you can also call these the x-intercepts, because this is where the smiley face intersects the x-axis, okay? Now, this thing over here is where it's clearly, this is the y-axis, right? And you can clearly see that this smiley face is kind of intersecting that y-axis. So this is what we know as our y-intercept, And then this bottom point right over here is what we call the vertex. We also call it it's mainly known as a vertex, but it can have other names like a stationary point, or a turning point, or a minima, because it's the minimum value. So it's a minima. It's a minima. Basically, it's if you look at all of these values for y, you just keep on going down, 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 and then this right over here is actually the lowest value you can have for this smiley face. So we call it the minima. And so these are some names that you need to know. If you had a sad face, let's say your sad face did something like this, then again, in this graph, let's say actually I'm going to draw this. I'm going to draw this up over here. If I erase all of this stuff, then let's say I have a different quadratic equation and it has a sad face, and it looks something like this. Or actually not even like this. I'm going to draw another axis over here. So this is x, this is y, and this other quadratic equation, let's say it does something like this. So over here we would basically have 2 points of interest. That would be this point right over here, and at the same time it would be this point right over here. Now this point is again the vertex, right? Because it's that final point of this sad face. You can also call it the stationary point, the turning point. In this case, it's not going to be a minima, it's going to be a maxima. It's going to be a maxima, and the reason for that is because you will have all of these values for y over here. This, let's say, is -10. This would be then -5. That would be like 0, and then 1, 2, 3. So all of these values, these minus values, all of these values, this -5, this -10, they're all lower than this 0, right? And your vertex, it sits on that 0, on that y value of 0. So it's actually it's the maximum value that is possible for this sad face. It's the maximum. In other terms, instead of calling it a vertex or a maxima, you can also sort of understand that this point right here, it touches the x-axis. So over here, the vertex is also going to be the root of your equation, okay? And so you could have, for a smiley face, you could have the same case. Let's say your smiley face did something like this. You had a smiley face and it did something like that. So in this case, you would that right there would be your vertex, and then this vertex would also at the same time be the root of your equation. Why? Because it touches the x-axis. Why is it the vertex? Because you can see it's almost like this kind of endpoint, this tip of this smiley face. And this vertex is actually a minima. It's a minima because it's the minimum value that you can get. So smiley faces have minimas, and these sad faces have maximas. And again, then over here we kind of have this y-intercept. Your smiley face or your sad face could also do something like this. Let's say you have an equation that has a smiley face, and it does something like this. In this case, obviously, you would clearly have no roots. This would still be a point of interest. It's still your vertex. It's still the lowest point. It's still the maxima. But over here, there are no roots to this smiley face. You can clearly see this smiley face is never going to touch the x-axis. This right over here is obviously going to be your y-intercept. Now let me just clear it out. Sometimes you may see something like this, where you have a smiley face, and you can be like, oh well, I only see a vertex. Clearly, this smiley face does not have it does not have roots, or it does not have y-intercepts. But that is not true, because I only drew part of this smiley face, right? This smiley face is going to keep on going till infinity. So it's highly likely that over here it's going to cross the y-axis, and there's going to be a y-intercept. It's just that this diagram was so small that you could not see the y-intercept. On the other hand, this is clearly not going to have any roots because it's above the x-axis, right? It's above the x-axis. It's going to keep on going over there, but obviously it's never going to be able to cross the x-axis or touch the x-axis at any spot. So it's going to have no roots. So these quadratic equations basically have these smiley faces or these sad faces, and then the points of interest that we can see in these smiley faces and these sad faces are the vertex, which is the final point, you can say, of a smiley face or a sad face. They can have roots, which are basically areas where your smiley face or sad face touches the x-axis. They may not have any roots at all. They may have one root or they may have two roots. That depends on where the smiley face or the sad face is placed on the graph. And they can also have y-intercepts. Now, these two things, you are always going to see these two things. You are always going to see these two things. Roots, on the other hand, are you can see them by chance. There's a chance that you may get to have a root. There's a chance that you may not get to see a root. If your smiley face is above the x-axis, then obviously you will not get to see a root. If it just happens to just sit on the x-axis, then you will see one root. And if it does something like this, then obviously you are going to have two roots.